these are our polarimeters. So this is exactly the same as the picture that I showed you on my PowerPoint. Inside we've got the sample that's contained in this sample tube. There's a light bulb at the bottom. There's a polarizing filter that fits in at the bottom there as well. And there's another Polaroid in at the top here underneath this eyepiece. Now if you could just move the thing over the top for me. You can see that there's like a protractor on the top here, so I can twiddle the dial and change the angle of the Polaroid. Okay, now when I've got it set at 0, that should be exactly crossed, so it should be as dark as I can possibly get it. So I'll show you the view down the eyepiece in a moment so you can see, because it's not perfectly dark anyway, and there's a little bit of sort of judgment that has to come into play here. But the idea is that when you put the sample in, if it's optically active, it will rotate the light. And what you have to try to do with the dial on the top is to twiddle it and find the new position where it goes dark again. And then you can take the reading, and that tells you the angle of rotation of your optical isomer. So this is the view down the eyepiece. This is actually set at 0, so this is the darkest that it gets. So as you can see, it's not brilliantly dark in there. Okay, now as I twiddle it, hopefully you'll see that it gets brighter. So this is as the Polaroids are starting to become aligned. If I turn it right round so that it's at 90 degrees, then this should be as bright as it can possibly go. I'm not going to do that in case it's too dazzling. I'm going to set it back to 0 again, and you'll see that it's easier to try to figure out the point where it's darkest than the point where it's brightest, and that's why we try to set it up like that. So what I've done is to set these up so that I have a solution of this S isomer of limonene in this polarimeter. I've got a solution of the R isomer of limonene in this polarimeter, and in the middle I've got an equimolar mixture of both isomers. So we're going to have a look down the top and see if we can measure the angle of it and see if we can figure out whether they're doing what the theory predicts that they should do. So, do you want to just come? So at the moment this is set at 0. So this is the view down the eyepiece of the S isomer. And at the moment it's set at 0, so this is not the darkest that it can be. So I'm going to try rotating the eyepiece ever so slightly and see if we can get it to be a little bit darker. You can see it's starting to change colour, and I think for consistency I'm going to decide to set it on that kind of bluey colour as being the darkest that I can possibly get it to be. So if we have a look now, if you lift up, we have a look at the scale, we can see it's set on about -8 degrees. Okay, that's the angle of rotation of this isomer, which funnily enough is the S isomer, S minus. Okay, so this is the R isomer, and this is the view down the eyepiece with it set at 0. So I'm going to have a go at rotating this one now, or the lens on the top here, the Polaroid on the top, and see if we can get that to a dark position again. And we're going to try and match it to what we saw on the other one. So I think that's probably the sort of slightly bluer tone that I can get there. Let's stop there. Yeah. If you can lift it up, and we can see where this was set on the scale. And that's almost exactly 8 degrees in the opposite direction. So that's exactly what we were hoping to see, that these optical isomers, these enantiomers, rotate by the same angle in opposite directions. Okay, now this is the view down the eyepiece for the equimolar mixture. So this is also set on 0 degrees, and you can see that it actually looks quite dark in there already. Okay, now if I turn it to either side, you'll see that it's getting brighter that way. And if I try rotating it in the opposite direction, it's actually getting brighter that way as well. So the best position for this one to be, generally the darkest, is actually to be set, if you lift it up, on 0. Okay, if I just set it on 0 exactly, so pop it down in the eyepiece again. I think that's the darkest that we're going to be able to get this. So this shows that the equimolar mixture is doing what we expected, that there is no net rotation in one direction or the other. The darkest position is still set right on 0 degrees. So it's as though nothing has changed, nothing has happened. It's as though I could have put water in there.